This is week 3, and we are in chapter 2, AST 204, heat system design. And we're talking about human comfort now. What do we mean by human comfort? What kind of temperature we feel comfortable with, and your body can function properly. Too cold, and your body will shut down. Too hot, and your body will shut down to try to preserve your organs. So, as temperature-wise, it's between 65 and 85 degrees. That's our human comfort, depending on your age, activity. But usually, this is the general rule, between 65 degrees to 85. If you go design a senior home, probably they want you to have it at close to 80. If you're in the gym, what do they want it? 68, 70. What is the temperature for swimming pool?
75.
78 usually. 75 is cold, 78. How come it's warmer than the air? Because it's completely, water will be stuck to your body, so it's different. You feel it differently than air. Air is not a good conductor, so it's different. So above temperature of 80, your body start to perspire, start perspiration and sweat, and hopefully that sweat will cool off or evaporate. If it doesn't evaporate, then it did not serve its purpose. It will actually provide some kind of insulation, and your body does not cool off. So, thinking about that, when people say, I like dry heat, I don't like humidity. So if you go to Arizona, even though it's hotter than Florida, it feels better because you evaporate. You sweat, but you evaporate and you're cooling your body. You just keep drinking water. If you go to Florida, it's hot and muggy, your body is not, you're sweating, but it's going to stay on your clothes. It's not going to evaporate. That's the difference between humidity and dry heat. We talk also about thermal equilibrium. Your body will always generate heat, and it will want to dispense that heat. So even though our body is at 97 degrees, you cannot sustain 97 degrees. Why? Because your body is constantly generating energy. As a bypass of metabolism, your body is digesting food, it makes heat, and it's we are a warm body, warm-blooded. Body metabolism changes as you move. If you're sitting watching TV, probably you will need cooler climate. If you're sleeping, you need cooler temperature. If you're walking out, probably start feeling hot. Probably you feel hot now a little bit after moving. So you move a little bit, it's going to be hotter. Airflow is how we pump air around your body. So airflow is part of convection. So in the summer day, if there is no breeze, the temperature is the same, but you feel hotter. If there's breeze, it feels cooler. Why? Because the breeze is pushing the air around your body and changing the temperature. That's why you can sleep sometimes with a fan as long as the temperature is not too hot. So the fan is keep pushing the air film around your body.
Because if it's too hot, it's just
Yeah. And if it's hot, even if you use the fan, it's not going to help.
So does that make sense, like, to put a fan in the window? Like, is that like?
It's changing the air and creating a flow. So
It depends on how hot it is outside.
the air around your body does not stay the same. It keeps changing. Because no way the air in the room is going to be more than 97. So even if it's 80, 85, if you're moving the air and keep pushing the heat out of your body. We talked also about radiant heat and how it just waves. It does not need to heat whatever is between the heater and the object. So if you go to, I said a lot of restaurants, they have those radiant heaters, and it's not heating the air. The air between you and the heater is very cold, but you're getting hot from the radiation. So it's radiating heat to your body. Same thing with the infrared heaters in the fast food restaurants. The heat to the body. And we talk about degree day, which is also the design temperature. So we design for the coldest day of the year when we design for heating, and we design for the hottest day of the year if we design for cooling. Make sense? We cannot plan for the extreme. If you don't plan for the extreme, something extreme will happen and it will freeze your pipes, and it will be an issue. So last up to 2 years ago, in Louisiana, they had a cold spell, and it was not designed for heating at all. They don't get cold at all. So a lot of pipe froze, was extreme, and they had to go and work with that. And again, we have a lot of climate change, a lot of extremes in the last 2 or 3 years. So places that did not freeze now are freezing now, and it does happen. So So you have to design for the coldest day so you can work with that. Humidity. It's the amount of water in the air, how much the air can carry as a percentage of its own weight. Relative humidity measures how saturated the air is with the water vapor up to 100%. So if you look at your weather app, it will tell you humidity in percentage. And again, it plays a big part in our human comfort because it has to do with us sweating. Which season is drier, winter or summer? Winter is drier, in here at least. Winter is dry because most of the water already precipitated into rain or snow. So winter is very dry here. Summer is very humid. It can get up to 80–85%, and it feels very uncomfortable. It's really hard to breathe when it's very humid.
Well, it used to not be humid around here, it's just been more recently.
It changed, weather pattern has been changing. It measures how rapidly sweat can evaporate from the skin. So you go into your house in the summertime, it's very humid, you turn on the AC, you will notice that it will take at least a couple of hours for the humidity to decrease from the house. Then you start cooling the house. What is happening? What kind of heat are we absorbing from the house? Latent or sensible?
Sensible.
In the beginning.
In the beginning?
Latent.
Well,
Yeah, because you're absorbing all the moisture and the AC is dumping water in the outside. Once you finish the humidity factor, you got all the extra vapor in the air, you can start cooling it off. So that's why AC is, when you design an AC, you have to design for both sensible and latent heat. Otherwise, your AC is going to work as a dehumidifier and just pull out the water. A dehumidifier is just an AC. It's designed to pull moisture from the water, then it stops. The AC keep going. So, same thing. Humid air contains more heat than drier air. Humid air feels better in the throat and lung system. So we don't want the air to be too dry. If it's too dry, you'll feel like your throat being scratchy. It's really also hard to breathe. And also when you have a cold, you get a moisturizer in the winter time to help the body heal. Your body is 90%, 90 or 70? 70, something like that, either 70 or 90% water. So you're losing water through your body, it dries up, and you have to replenish that water. Warmer air can hold more moisture than colder. This is how we dry things up. If you have a hair dryer, that's what it's doing. It's warm air. The warm air attracts more moisture and can carry it somewhere else. Relative humidity, RH, relative humidity, depends on the rainfall, closeness to a body of water, clouds, winds, and indoor humidity depends on the temperature of the air you take from the outside. So if you live near a lake, near the ocean, you're always going to have some kind of humidity. That's why the temperature in Boston is always 5 degrees different than here, because it's close to the ocean. So Springfield is colder than Boston, even though it's only like, what, 60, 70 miles away. But the ocean kind of offset the temperature. And the ocean is a big storage of temperature. So it's 10 to 5 degrees different than here. So the humidity is how close you are to a body of water. Also the elevation make a difference, and pressure. So they're all kind of interrelated when it comes to humidity and temperature.
Wait, you said Springfield's colder than Boston?
Yeah.
Really?
Yeah.
You want the ocean be close to Boston?
The ocean actually, it warms the weather instead of cooling. Yeah.
Is that all year round, or is that depend on the time of year?
It's all year round.
Oh.
Those 5 degrees difference. Even in hot summer days, it will be hotter here than Boston, I'm sure, because the sea breeze is always going to equalize. Water holds more temperature.
So it's kind of like a heat sink.
Yeah. Storage in a way.
Yeah.
So we want humidity to be for the human body at 60%, we want less than 60% and more than 40%. So to repeat, human comfort, temperature between 65 degrees to 85 degrees. Humidity 40% or 60%. So this is going to be our goal in the winter, because winter is dry, right? In the summer, want to keep it down to 60%. We can do more than that, but it's going to cost you energy. And every time, again, we have these kind of processes and use a refrigeration cycle to heat or cool, you will put some energy. So we try to be within the limits. So HVAC means, how are we going to achieve this human comfort in a building or a house? So these are our modern means. We used to burn wood in the past. Now we do combustion, but we do not burn mostly wood, either gas or oil. So combustion to make heat, and it's still the most viable, most common method. Then we can use electrical heat, which is two types, either coil that you heat, or infrared, or a heat pump. Those three are electrical. The refrigeration cycle is also electrical, but this can be used for heating and cooling, which is again the heat pump. It heats in the summer and it cools in the winter. So this is what we have so far. There are other means we can do, like geothermal or passive heating and cooling, but for now, to offset this amount of temperature, we have to put in some energy. Either we gotta burn something, or use a heat pump, or use electrical coil or infrared.
Is that why space heaters are dangerous in the households, because they generate too much heat?
Yeah.
When strong current?
Yeah, they draw a lot of current. The rating on those is like 1.5 kilowatt, 1500 kilowatts. It's a lot of energy. And they have a lot of safety means now. You can buy one for $30 that if it tips over, it's going to shut off. If it's overheat, it will shut off. And they always tell you, do not plug this into an extension cord, plug it directly into the wall. And they also tell you, do not leave it unmonitored. They generate a lot of heat and they draw a lot of amperage. So, and probably if you have two of them in one room, it will definitely trip your circuit breaker. And again, you're gonna pay a lot for that. So, it's going to be around 30 cents an hour to run this thing. So, you do the math, 10 hours, that's around $3 a day. And you keep adding bills. So those are the space heaters. However, electricity is very efficient. So if you put in 1,000 kilowatt, you're gonna get the same, almost the same amount of that energy into BTUs, but it's expensive. So to recap, we talked about energy transport. That's convection, conduction, and radiation. We talked about human comfort, climate, which is the weather over a long time. How does the climate affect what energy need we require? Temperature around us, how it's different to build your house uphill or downhill, close to the water, farther from the water, humidity. This also affects your material selection. Some insulation, they cannot take a lot of moisture. So it depends where you live and what kind of material goes with that. Humidity, energy for home use. You're gonna use a lot of energy, and again, we said 70% of our energy consumption is for heating and cooling houses. Combustion needed, we're still going to burn gas or oil to heat the house. And the heat pumps are a good option, but it's not viable for the entire year in New England. You can use them all year except for 2 months, January and February. You need to have a subsidy or secondary gain of heat. And if you insist to run them during the cold weather, the efficiency goes down. Even though the killing is 85, the colder it is outside, the less efficient it will be. Bless you. It's easier for you to hold heat when it's around 30 or 40. Some of them can work up to like 10 degrees, but again, it's going to work harder to do that. So it's not very viable. Electric resistance heating, you can see those in AC sometimes, especially like ACs that do not work all the time. They put some coils in the vent to heat the air. However, it's basically a blow dryer. So it's not very efficient, and again, it dries the air very quickly. And finally, the refrigeration cycle, which is an air conditioner or a heat pump that can work for the summer and the winter. So quiz on Friday, we're on Friday already. Chapter 1. Let's do that. Thank you.